In this video, we will be discussing some troubleshooting method used in the multicast RPF, which is reverse path forwarding failure. Firstly, we will talk about the understanding of the multicast RPF check and followed by various ways to troubleshoot it. And in the last, we'll see how to modify RPF check followed by the lab demo. What we know about RPF check, like before troubleshooting, at least we should have some understanding about it. So like I said, like PIM does not exchange its own topology information, so it's always dependent on IGP protocol to provide loop free path and end to end connectivity. So in conclusion, RPF work is to make sure that there aren't any loop in the network, and it is a kind of extra layer to provide loop free topology. So in the last conclusion is, or the logic behind is, if incoming multicast interface is equal to the outgoing unicast interface, then in that case RPF checks passed. If not, RPF checks failed. So based on the three types, ways of checking about RPF changes. So like I said, like shortest tree is the shortest part between sender and the receiver. And in shortest tree case, we always perform some RPF checks against source. It is used in a PIM dense mode as well as in PIM sparse mode as well. While in sparse mode, we perform RPF checks from RP towards source, and in RPF checks from receiver to source after SPT switchover, which I will be going to discuss it in the next slide. Uh, and the shortest tree also used in source specific multicast. Now coming on shared tree, the RPF checks were done against RP. Wherever we see star comma G entry, that denotes shared tree, and in sparse mode RPF checks were done from receiver to RP before SPT switchover. Like I said, RP always should have route back towards the source or route towards the sender. And if this condition fail, definitely in the multicast routing table, S comma G entry will not be created. So with the help of this topology, I'll try to explain you or talk about the SPT switchover, which is nothing but shortest path tree switchover. So in the below topology, I have taken 7 devices, device 1 being the sender and device 5 I have configured as a RP router and device 7 being the receiver. So shared tree consists of two shortest path. The first path is device 5, which is the RP router towards the sender, which is marked in red, and the second shortest path is device 7 from device 5, which means from receiver to RP. So basically shared tree is the combination of two shortest path, from device 7 to 5 and from 5 to 1. And overall shortest tree is from device 7 to device 1, which is marked in black. So in that case it won't touch device 5. So in this phenomena, what happened, once the shortest path is once the shortest path is known, then device 5, which is the RP router, send a prune message to all the connected interface. In this topology means it will send prune message to device 4 and device 3, and after that all the communication were done by from device 7, then 6, then 4, then 3, then 2 to 1. It won't the traffic won't flow from device 5. So basically traffic flow started from shared tree, and now it switched to shortest tree. So that's phenomena called shortest path tree switchover. So RPF is totally dependent on the unicast routing condition. If any changes occur in the unicast routing, it will going to affect multicast route as well. As PIM protocol does not exchange its own topology information and very much relies on unicast route, some modification can be done with manually adding IP route or the static route, or dynamically with multicast BGP also. some modification can be done.